series, sorry. We're going to show that this series converges. Now, the test that will be convenient for us, to determine whether the series converges or diverges is the ratio test. Okay? Because we have the factorial here, so it would be difficult for us to use we are testing for convergence, right? So now what does it mean by the ratio test? For you to use the ratio test, what does it mean what is required of to determine if it converges or diverges? So let me just run you through. If we use the ratio test, we take the limit as n approaches infinity over an plus 1 over an. If this, ladies and gentlemen, is equal to L, and it so happens that L is less than 1, then we can conclude that our series does what? Converges. Same if we take the limit as n approaches infinity, we apply the if we find that this is greater than 1, meaning our series diverges. So, this one, we are saying Ly, but if we find a number L, and it so happens that this L is less than 1, then our series converges. That's by the ratio test. Are we clear up to here? Yes. So this, using the ratio test, we can apply this now. So now we're going to take the limit as Zn over n factorial approaches infinity. Then we will determine if it is less than 1 or greater than 1. If it's less than 1, converges. If it's greater than 1, it diverges. So now, let's proceed. So we'll say the limit as n approaches infinity, the absolute value of z to the power n plus 1, according to this, over n plus 1 factorial, divide by this, which is an z to the power n over n factorial. Okay? So now here, this can swap, right? They can swap. So this becomes the limit as n approaches infinity. Applying index rules, this is the same thing as z to the n multiplied by z over n plus 1 factorial. If we change the sign to multiplication, this swap. Right. This goes there and that goes there, and this is n factorial over z to the power n, like that. Yeah? So, grade 1 to subtracting, I'm watching the sign of multiplication, then this.
Yes. Since I'm the moderator, yeah, therefore you have skipped one stage, sir.
Okay.
this function you've said according to the explanation you've given, it converges when that value L is less than 1. But we need also to try when that Z equals 0, so that we see when it is, and we take values when Z is not equal to 0.
Okay. Mr. Chris. Mr.
Kafunda.
Mr. Kafunda. Let me answer your question. The question says, determine whether the series converges or diverges. Whichever route you use to test, there are infinitely many routes to use, infinitely many tests that you can use to find the same answer. There is the ratio test, the Shanshan test, the root test, and those all sorts. So here, since it says that show that the series converges, it's absolutely right.
Why the absolute?
Absolute convergence. Sorry. So we are testing for absolute convergence. Yes, we are on the right track actually. So here, what we need actually, we are on the right track. Don't put that. We are on the right track, Hope you've copied this, for us to test that the series converges absolutely, we need first to test that the series converges. If Zn Okay, ladies and gentlemen, let me take you back. For us to determine whether a series converges, absolutely. First of all, Zn should converge, If Zn converges and the absolute value of Zn converges, then we say the series converges absolutely. Alright? Now, let's say if this diverges, then this converges, or this converges, then this diverges, we say it's a conditional convergence. Okay? So now here we are trying to determine first if just Z without the absolute values, whether it converges or diverges, which we are doing by the ratio test. Then after that, we need to show that the absolute value of Zn converges or diverges. Then we can conclude if it's absolute convergence or conditional convergence. We are together. So we proceed. So we are testing. We are testing if this converges or diverges. So, ladies and gentlemen, here, this we need to get rid of this and that. These are the same, and they are over each other. When you have A over A, it's the same thing as this crossing. If chala cancer, ichi nechala cancer. Then put to cancer and H. We need to expand this. To expand that, we are going to have Z over a parashara Z. Then we have over N plus 1 factorial times, we expand this, N minus 1 factorial. We need, sorry. We need to expand this, sorry. So that this and this cancels out.
So it's minus 1.
Okay. So, ladies and gentlemen, if we expand this, it's the same thing as N plus 1 multiplied by N plus 1 minus 1 factorial times N factorial. You get that? So this So this becomes